The topic of sets is by far the simplest topic to grasp in mathematics since we have to tackle just three simple questions. First, what are sets? Second, why do we need them? And last, how do we represent them? Let's tackle the first question in this video. What are sets? A set is basically a collection of things. Think about it. What if you were asked to make a list of all the things you can see? Of course, you can't write all the things, but some of the things you would mention are a tree, a cell phone, a puppy, people, and so on. And what if you were asked to write down a list of things you cannot see? You would probably write oxygen, heat, and so on. These are the things you cannot see. A set is a collection of elements, yes, but they have to be related in some way. Let us look at a few more examples to understand better. Try to list down all the cricket-playing nations you know of. I would probably have said India, England, Australia, Pakistan, and so on. Now try to list all the oceans you've heard of. If you didn't know, there are 5 oceans in the world: Pacific, Atlantic, Indian, Arctic, and Southern Ocean. Now here's an interesting question. Can we make a set of elements for all the questions you're asked for? The answer is no, not necessarily. What if we were asked to make a list of the good teachers we know? We cannot make a set here because my idea of a good tutor may be completely different from yours. Similarly, we cannot make a list of intelligent students we know. The word intelligent is not well defined. So remember, another important characteristic of sets is that the elements in it should be well defined. All the elements in a set should be related and well defined.
Hello friends, let's have a look at these images. What do you think about them? We have a bunch of keys, a school of fish, a group of letters, a pile of books, and a bunch of flowers. The one thing that can be seen in common is that everything is in the form of a group or set. And well, that's our topic for today. Sets. But what exactly is a set? A set can be formed of anything that can be well defined or distinct. Now, let's see what do we mean by well defined or distinct. Let's take an example. A set of numbers from 1 to 10. Now this is well defined. You can list all these numbers also, right? So this can be a set. Let's consider another example. A set of smart students or a set of generous people. Can this be considered as a set? No, not exactly, right? Because here, smart or generous cannot be defined or measured, or we can say that these are relative terms because the meaning of these words will change from individual to individual. Hence, we cannot make a set of these situations. Let's take a simpler example. A set of all the letters that comes after T. So what all letters will be there? U, V, W, X, Y, and Z. Yes, so this can be also called as a set, right? Let's see a few of these examples if we can form a set of them or not. The first is states of India. So, can we form a set of this? Yes, because there are 29 states in India and you can list all of them. The second one is strong students in a class. Well, this cannot be a set because strong is a relative term. But suppose here if I'll add a condition like students who weigh more than 50 kg in a class are to be considered as strong. Can now this be formed a set? Yes, because now we have a number, a quantity, or a well-defined and distinct property that we can use and form this set. Right? Let's see the next one. Students who have scored 70% and above in the last semester. Yes, you can form a set of this. Collection of great people in the world. Again, great is a relative term and we cannot form a set of this. So I hope by now you know what are sets and in which conditions we can form a set and cannot form a set. Let's move to the next step. So how do we present these sets? There are two different ways to write these sets. One is listing method or also known as roster method. The second is rule method or known as set builder method. Let's see what listing or roster method is. If I want a set of all letters in the word mathematics, then how will I write it? Well, this is a very simple method. Let's look at this in a little more detail. All the letters in the brace or curly brackets are known as elements. A or any letter can be used to represent this set. However, there's one tiny mistake that is there in this set. The elements in this set are never repeated. Every element appears just once in a set. Hence, the solution of this set of all the letters in the word mathematics will be A is equal to curly brackets M A T H E I C S curly brackets closed. This is how we present a set in a roster method or a listing method. Now since just we have listed all the letters is the reason why it is known as a listing method. Next can be a set of all the days in a week, a set of all the rainbow colors, etc. We have also been studying sets in few of our previous grades. It's just that we never knew that they are sets, like a set of natural numbers, a set of whole numbers, a set of integers, etc. Sets are used in a variety of places in mathematics, but we'll see that in the future sessions. So now I believe you can make any set using the listing method. Now what happens if I ask you to form a set of all the whole numbers between 0 to 10,000? Can we use this listing or roster method to list all these whole numbers till 10,000? No, right? Hence, we have this rule method or set builder method. Now since we are building a particular set, instead of writing all the elements in the set, this is known as a set builder method. Now a set using set builder method is written like this and is read as A is a set of all x such that x belongs to whole numbers and x is a whole number between 0 to 10,000. Now, was this a little difficult? Let's try another set. Now, can we represent the set of all letters in a word mathematics in the form of a set builder form? Well, yes. Let's name this set as B. B is a set of all x such that x is the letter of the word mathematics. Every set can be represented in the set builder form. Try a few of these sets in the form of listing as well as set builder method. Now, why this method is known as a rule method? Now here we can see that we have added certain conditions in this set. This is the reason why this is also known as a rule method. So till now we have seen that what is a set, things that can form a set, and ways to represent these sets. In our coming sessions, we will see what are the different type of sets and also about the Venn diagrams. I hope this session was useful to you. If you have liked this session, please hit the like button. Do comment down your queries and don't forget to subscribe our channel. And don't forget to hit the bell icon and never miss another update from Let's Tute. Till then, keep watching, keep learning. Thank you.
Hi guys! Welcome sa Engineered Math Channel. Sa video na to ay tuturo ko sa inyo ang introduction to sets. So kung gusto niyo itong matutunan, just keep on watching. Okay, so this time ay tuturo ko naman sa inyo ang introduction to sets. So, magkakaroon tayo ng different terminologies about sets as well as ano-ano ba yung mga different notations, descriptions kapag naka-encounter tayo ng sets. So, define muna natin kung ano ba ang set. So, sabi, set may be thought of as a collection of objects and these objects are called elements or members of the set. So, pag sinabi nating set, collection siya ng objects. So, yung objects dito is sinatawag nating elements or members ng set. So, pag sinabi nating set, para siyang grupo ng objects na merong certain description. And then, group sila as isang set. So, example, a set of silverware, a set of tires for a car, a set of encyclopedia, a set of dishes. In mathematics, so this is the most important applications of sets. So we have example of sets in math such as a set of counting numbers, a set of integers, a set of points, a set of solutions for an equation. So ito yung mga possible examples ng sets sa math, which is hindi lang ito, marami pa tayong examples ng sets. So kapag sinabi nating set sa mathematics, well-defined. Meaning, if we are given a particular object, we know whether that particular object is an element or not of the set. So, halimbawa, kapag sinabi nating set of integers, so alam natin agad yung magiging members nung set na yon. Like for example, any set of integers like negative 2, negative 1, 0, 1, 2, 3, and so on. So, ibig sabihin, well-defined siya kasi alam natin kung ano yung mga members or elements nung set na yon. Pag sinabi naman natin not well-defined, hindi tayo sure or subjective siya. Yung pwedeng maging elements or members nung set is depende sa opinion ng tao. So, as an example, meron tayong mga different sets dito. So, identify natin kung well-defined or hindi. For letter A, the set of all large number. So, this type of set is not well-defined. Kasi iba-iba naman yung opinions ng tao sa malalaking numbers. For example, pag sinabi natin 100,000, malaki na yun para sa isang tao. Pero yung ibang tao naman kino-consider na mas malaki kapag 1 million yung number. So, iba-ibang opinion ng tao dito sa set of large numbers. So, kaya not well-defined. Next, the set of all multiples of 3. So, this time, well-defined na siya kasi alam naman natin yung mga multiples of 3 na numbers like 3, 6, 9, 12, and so on. So, ibig sabihin, defined siya kasi alam natin yung members. Next, si set of good writers. So, just like in A, hindi rin ito well-defined kasi nga, iba-iba rin yung magiging opinion natin kung sino yung mga good writers. Next, the set of nice people in your class. So, obviously, not din kasi iba-iba yung pananaw natin sa ugali ng tao. So, pwede mong masabi na nice yung kaibigan mo, pwede na naman sa ibang tao hindi nice yung kaibigan mo. Okay? Next, set of odd integers. So, this time, it is a well-defined set. Kasi alam naman natin yung mga odd integers like 1, 3, 5, 7, and so on. Okay? So, yung difference ng well-defined at not well-defined sets. Next, let's have the notations for set. So, traditionally, we use capital letters such as capital A, B, C, D, and E to denote sets, and lowercase letters as small letter A, B, C, D, and E to denote the elements of a set. It is also a common practice to list the elements of a set in braces or this symbol and separate these elements by commas. Okay, so sabi, kapag magsusulat tayo ng notation sa set, pinapangalanan natin yung set ng capital letters. So, halimbawa, we have the set A. So, gumamit tayo ng capital letter to name this set A. And then, para naman doon sa members or elements ng set natin, usually small letters na. And then, naka-enclose sila sa braces and separated sila by comma. So, halimbawa, itong dinonote natin na set A, capital A, equal siya sa mga elements, so inside the braces, which are 5, 10, 15, 20, 25. Each elements are separated by comma. Okay? So, pwede nating sabihin na 5 is a member of A, So, itong symbol natin na to denotes membership. So, ibig sabihin, 5 is a member of A. Kasi nasa list siya nung members nitong A. Also, 20 is a member of A. Kasi yung 20 is included sa elements. Kapag sinabi naman natin hindi member, let's say, 30 is not a member of A. So, lalagyan nyo lang ng slash yung original symbol na membership. Kasi nga naman, hindi naman member itong 30 dito sa set A. Okay? Ngayon, meron tayong tinatawag na empty or null set. So, from the word itself, a set with no elements. So, ang symbol is this one or this one. So, kapag walang elements or members yung set, tinatawag silang empty set, literally. So, halimbawa, we have set B, capital B, equal to empty set or null set. C equal to empty set or null set. Ibig sabihin, walang members. So, tulad nito, meron lang tayong braces pero walang nakalagay na members. Okay? Now, kapag yung set is nagko-contain ng elements, sometimes we often use 3 dots or ellipses para ma-indicate natin na merong elements in the set na hindi natin nasulat. So, halimbawa, set of whole numbers W, okay, equal to, alam naman natin yung members nun, right? Mag-start siya sa 0, 1, 2, 3, and so on. So, yung so on ko, ginamitan ko ng ellipses or 3 dots. Ibig sabihin, magko-continue pa siya infinity. Kasi hindi naman natin masasulat lahat set of whole numbers. So, sinulat ko na lang yung ellipses para ma-denote na continuous pa yung members nitong whole numbers. Okay? Next, pumunta naman tayo sa description of sets. So, meron tayong 3 ways of describing a set. So, yung una is sinatawag nating the roster notation or listing method. So, this is a method describing a set by listing each element of the set inside the symbol brace. In listing the elements of the set, each distinct element is listed once and the order of the element does not matter. So, ito yung type nung description ng sets natin na ginamit natin dito sa example. Okay, set A with elements 5, 10, 15, 20, 25. So, basically, ililist lang natin inside the braces yung mga members ng set. So, halimbawa, dito sa set A, it has an element 1, 2, 3, 4. Set B, it has an element inside the braces with small letters P, H, I, L, N, E, S. Set C, with elements inside 5, 10, 15, and so on. And D, with elements inside the brace as the word moon. Okay? So, yun yung roster notation or listing method. So, ito yung ginagamit natin kapag nililist natin directly yung mga members ng elements. Okay? Now, meron tayong pangalawa, the verbal description method. So, from the word itself, verbal description method, i-define lang natin, for example, etong mga sinet nating example dito sa A. So, halimbawa, dito sa A, so, A is equal to elements 1, 2, 3, 4, right? Kapag describe natin in verbal description method, set A is the set of counting numbers less than 5, right? So, lahat sila counting numbers starting from 1 up to 4 and therefore they are less than 5. Okay? Set B. Set B is the set of letters in the word Philippines. So, tama nga naman kasi meron tayong P, H, I, L, N, E, S. So, bakit kulang? Hindi natin sinulat lahat ng letters sa Philippines like double P, double A, triple I, and so on. Kasi sabi natin sa description natin sa sets, right, sinusulat lang natin once yung nare-repeat na members. So, kahit na-repeat 3 times itong I at itong P ng 2 beses, isusulat lang natin sila as a single letter P and a single letter I dito sa listing method. Okay? 3, ma-define natin yon as set C is the set of positive multiples of 5. So, tama, di ba? Kasi yung mga members niya is 5, 10, 15, and ellipses. Ibig sabihin, continuous pa siya. Pwede pang magdagdag such as 20, 25, and so on. Okay? Next, for D, set is the set of a natural Earth satellite. So, tama, di ba? Moon is a natural Earth satellite. Okay? Now, for the third type, we have the set builder notation. So, it is a method that lists the rules that determine whether an object is an element of the set rather than the actual elements. So, we can describe the sets named in 1 as follows. So, kung i-describe naman natin in set builder notation, again, yung mga sets natin in 1. So, ibig sabihin kasi ng set builder notation, dinidescribe natin sila pero hindi natin sinusulat directly yung elements. So, gagamit tayo dito ng symbol na x such that x or this symbol. So, halimbawa, yung set A, alam natin na yun yung mga number less than 5, right? So, susulat natin yon as x such that x is a counting number less than 5. So, yung sumunod, pwede nyo nang i-apply yung verbal description doon sa set. Okay? After nitong symbol na x such that x. So, sabi, the set of all x's such that x is a counting numbers less than 5. So, yun yung basa doon. X such that x. Okay? So, sabi yung bar nga after the first x is read as such that. Okay? Next for B. So, ganun uli. X such that x is a letter in the word Philippines. So, same lang dun sa description sa B, right? Next, C. X such that x is a positive multiple of 5. Okay? And lastly, D. X such that x is a natural Earth satellite. Okay? So, yun yung set builder notation. So, usually ginagamit to sa mga solutions of equations. For example, x such that x is a member of real numbers, or pwede rin sa domain and range of relations or functions. Makakita kayo ng set builder notation. Okay? Next, the cardinal number of a set A denoted by n of A is the number of elements in the set. Okay, pag sinabi natin cardinal number or cardinality, ito yung number ng elements ng set. For example, let's say we have set A with elements A, E, I, O, U. So, pag binilang natin yung number ng elements itong set A, we have 1, 2, 3, 4, 5. So, therefore, n of A or the cardinal number of A is equal to 5 because set A contains 5 elements. Okay? Now, meron din tayong equivalent sets. So, sabi, two sets that contain exactly the same number of elements. So, kumpara yung cardinal number ng dalawang sets, then equivalent sets sila. Halimbawa, set A with elements 1, 2, 3, 4, and set B with elements M, A, T, H. So, kahit magkaiba sila ng elements, pero pareho sila ng number, then equivalent sets sila. Okay, pareho silang 4 elements. Now, for equal sets, two sets that contain exactly the same elements. So, this time, kapag parehong-pareho naman yung elements ng dalawang sets, kahit magkaiba yung order ng elements dun sa bawat set, then equal sila. Halimbawa, set A with elements A, E, I, O, U, and set B with elements E, O, I, U, A. So, exactly the same yung mga elements na involved sa kanila. So, equal set sila. Okay? Next, let's have the universal sets and subsets. So, there are cases where two or more sets contain some but not all of the same elements. For example, meron tayong set A with elements 2, 4, 6, 8, and so on, or even positive integers, right? And meron tayong set B wherein we have the elements 1, 2, 3, 4, and so on, or natural numbers. So, mapapansin nyo, yung 2 is a member ng A, likewise 2 is a member of B, 4 is a member of A, likewise, 4 is a member of B, and so on. So, ibig sabihin, lahat ng merong element si A is element din ni B. So, kapag gano'n, tinatawag natin na A is a subset of B. Or we can use this symbol. So, therefore, A is a subset of B. So, sabi, given any two sets A and B, if every element in A is also an element in B, then A is a subset of B. So, ganon. So, masasabi nating subset, ang isang set nung another set kung lahat ng elements ng naunang set is nandun din sa elements nung pangalawang set. Tulad nitong A at B. Okay? Note, every set is a subset of itself. A subset of a given set that is not the set itself is called a proper subset. So, tandaan nyo yun. Kapag meron kang isang set, automatic subset niya yung sarili niya by this sentence. And then, kapag hindi itself yung tinuturing na subset ng isang set, tinatawag natin yon na proper subset. Sasabi, if A is a subset of B, and there is at least one element in B that not contained in A, then A is a proper subset of B. So, halimbawa, meron tayong set A with elements A, B, C, and set B with elements A, B, C, D. So, mapapansin nyo, lahat ng elements ni A is nasa elements din ni B. So, therefore, A is a subset of B, tulad dun sa kanina. Pwede rin nating masabi na A is a proper subset of B kasi, from the definition, merong at least isang element si B na wala si A. Ano yon? Etong D, right? So, therefore, A is a proper subset of B. So, yun ibig sabihin ng proper subset. Note daw, the empty set is a subset of every set. So, tandaan nyo yun, kapag meron tayong empty set, kino-consider siya na subset ng lahat ng sets. Okay? So as an example, we have determine all the possible subsets of the set. For A, we have set A equal to the elements 1 and 2. And for B, we have the set B equal to the elements 1, 2, 3. So muna tayo sa A. So ano na yung mga possible subsets nitong A? So apply natin yung note natin kanina. So unang possible subset nitong set A natin is yung set A itself, right? So set 1, 2. Ano pa? Yung empty set or null set. Laging subset yon ng every set. Ngayon, kapag i-consider natin yung element nitong A, 1 at a time, pwedeng maging subset niya is 1, pwede ring maging subset niya is 2. So, we have a total of 4 subsets for set A. Okay? So, for B naman, again, yung subset niya pwede yung mismong set B. So, we have set 1, 2, 3, and then yung empty set. And then this time, pwede tayong kumuha ng 2 elements at a time. So, pwedeng set 1, 2, pwedeng set 1, 3, pwedeng set 2, 3. And then, pwede ring 1 at a time. So, set 1, set 2, set 3. So, ito na yung set 4, 3 elements taken 3 at a time, right? So, ilan lahat to? 1, 2, 3, 4, 5, 6, 7, 8. So, meron tayong 8 subsets for set B with 3 elements, 1, 2, 3. Okay? Or actually, we have a note here. If a set contains n elements, then it has 2 raised to n subsets. So, as an example, ito sa set A natin, ilan yung number of elements natin? Or cardinality niya? 2, right? Kasi meron tayong 1, 2. So, therefore, ang formula natin para sa number ng subsets niya is 2 raised to n. So, we have 2 raised to n is 2. So, we have 4. So, pag binilang natin, tama, 4, diba? Same as dito sa B. Ano ba yung number ng elements ni B? Tatlo, right? 1, 2, 3. So, therefore, using this formula, we have the number of subsets 2 raised to n or 2 raised to n is 3. 2 to the third is 8. So, same sa na-compute natin. Okay? Next, we have the universal set. So, universal set is the set of all possible elements of any set used in the problem and is denoted by letter U, capital U. So, pag sinabi natin universal set, ito lang yung possible elements na kino-consider natin sa problem. So, wala nang madadagdag pa doon. So, iba-iba yung pwede natin maging universal set depende sa given problem. So, halimbawa, meron tayong universal set dito na 1, 2, 3, 4, 5, 6, 7, 8, 9. So, hindi na pwedeng lumagpas pa dito yung magiging involved na elements natin. 1 to 9 lang ang involved elements. Kasi kapag nagkaroon tayo ng another set, let's say A na merong elements 1, 2, 3, 10, 11. So, hindi na magiging consider na universal set itong U kasi merong itong A na wala sa universal set natin which is 10 and 11. Okay? So, dapat yung gagamitin nyo ng symbol na universal set is yun lang yung lahat ng possible elements na may involved dun sa problem. Okay? Now, pag sinabi natin the complement of a set A is the set of all elements in the universal set U that are not in the set A. The notation for the complement of A is A prime or this symbol. So, pag sinabi ng complement, so gagamitin natin dito yung universal set. Let's say meron tayong given set A, hanapin natin yung complement niya or A prime. Hanapin natin doon sa universal set yung elements na wala siya. Okay? So, halimbawa, nagbigay ako dito sa ng element A na merong 2, 6, 7, 8. So, pag hinanap natin yung A prime, hanapin natin dito sa universal set yung wala sa A. Ano-ano ba yun? 1, 2 meron, right? 3, wala. 4, wala. 5, wala rin. 6 meron. 7 meron. 8 meron, and then 9 wala. So, ito yung A prime natin. 1, 3, 4, 5, 9. Meron sa universal set na wala sa A. Okay? So, more examples. Given universal set U equal to 1, 2, 3, 4, 5 and set A equal to 1, 3, 5, find A prime. So, A prime, hanapin natin sa universal set yung wala dito sa A. So, ano-ano yon? So, 1 meron. 2, wala. 3, meron. 4, wala. 5, meron. So, ito lang. A prime is equal to 2, 4. Okay? Now, for 2, given universal set equal to 1, 2, 3, 4, 5, B equal to 1, 5, and C equal to empty set. So, find B prime and C prime. So, B prime. Hanapin natin yung meron sa universal set na wala sa B. Ano yon? Obviously, meron yung B na 1, 5. So, yung wala lang dito is 2, 3, 4 sa universal set. So, 2, 3, 4. Okay? Next, for C prime. So, yung C natin, mapapansin nyo, empty set. So, therefore, lahat ng meron sa universal set is wala dito sa C. Kasi wala siyang laman, di ba? So, therefore, C prime is equal to the universal set or 1, 2, 3, 4, 5. Okay? Okay, so I think that's it for this video introduction to sets. So, sana ay may natutunan kayo sa video na to at maraming salamat sa panonood.
Now let's say if we have set A, which contain the elements 2, 4, 5, 6, and 9. And we also have set B, which contain the elements 2, 3, 5, 6, 7, 9, and 10. So what is the intersection of set A and B? How can we get the answer? To find the intersection, we need to find out which elements are common to both sets. So both sets contain a 2, they contain a 5, a 6, and also a 9. So therefore, the intersection of sets A and B is 2, 3, actually not 3, but 2, 5, 6, and 9. And that's it. So that's how you could find the intersection of two sets. So now let's work on some more examples. You can pause the video and try this one if you want to. Let me use some different letters. So let's say this is set C, and it contains the elements 3, 4, 6, 7, and 10. And also set D, which contain the elements 3, 6, 8, and 9. So feel free to pause the video and determine the intersection of sets C and D. Go ahead and try it. So which elements are common to both sets? So 3 is common to both sets, 6, and that's it. So for this particular example, it's only 3 and 6. So that's the intersection of the two sets. So this is the answer. Let's try another example. Let's say set F contains the elements A, B, C, D, F, G, and J. And set G contains the elements A, C, G, H, and K. So what is the intersection between sets F and G? So feel free to take a minute and try it. So let's see which elements are shared between both sets. So both sets contain element A, element C, G, and that is it. So the intersection of F and G is going to be A, C, and G. So as you can see, finding the intersection is pretty straightforward. But now what about this particular example? Let's say set J contains the elements 5, 7, 10, and 11. and set K has the elements 2, 4, 8, and 13. What is the intersection of J and K? Now notice that there is no common element shared between the two sets. The elements in J are completely different from the elements in K. So in that case, the intersection of J and K is going to be empty. There's going to be nothing inside. So if there's nothing inside, if you have an empty set, you have a null set. So this is the answer. You have to use a Greek symbol phi. Now let's say we have set R, which contains the numbers 3, 4, 7, and 10, and set S, which is basically an empty set. What is the intersection of R and S? The intersection of a set with numbers and an empty set is going to be another empty set or null set. So that's it for this one. Now let's focus on the second type of problem that we need to talk about, and that is to find the union of two sets. So let's say that set A contains the elements 1, 2, 3, and 4. And set B contains the elements 3, 4, 5, and 6. So what is the union of these two sets? When I think of union, I think of combining these into a larger set. Now notice that we do have some common numbers, 3 and 4. Now the union will contain everything in both sets, but 3 and 4, we're not going to write it twice, only once. So the union of set A and B is going to be 1, 2, 3, 4, 5, and 6. So we're going to write everything in both sets, but only write it once. So let's try some other examples. So let's say set C is 3, 5, 9, 11, and 13. And set D is 2, 3, 6, 8, and 12. Go ahead and find a union between sets C and D. Go ahead and try that. So all we got to do is just write all the numbers in C and D. So let's put it in ascending order. So we have a 2, a 3, there's a 5, a 6, there's no 7. So we have an 8, a 9, there's no 10, but we have an 11, 12, and 13. And so that's it. So that's the union of those two sets. Here's another example. Let's say that set J contains the letters A, C, D, and E, and that set K contains the letters A, B, F, E, and G. Go ahead and determine the union between J and K. So just like before, all we need to do is write all the letters. So we have an A, a B, C, D, E, F, and G. And that's it for that question. Let's say that set X contains the numbers 2, 5, 8, 12. And set Y, let's say, is an empty set. What is the union of a set with numbers and an empty set? Well, the empty set is not going to add anything. It's like saying 15 plus 0, that's going to be 15. So therefore, the union of set X with an empty set Y is going to be the same as set X. It's 2, 5, 8, and 12. It's not going to change. But the intersection of a set with something and a set with nothing, it's going to be an empty set. So just something to keep in mind. Now, here's a question for you. Let's say if set A contains the numbers 3, 4, 5, and 7, and set B contains the numbers 2, 4, 5, and 8. How can you determine the intersection of A and B and a union of A and B and represent the results using a Venn diagram? So circle A and circle B in its separated form. Set A contains the numbers 3, 4, 5, and 7. B contains the numbers 2, 4, 5, and 8. Now, the intersection of these two, I'm running out of space here, is 4 and 5. 4 and 5 are found in both. But to represent that using Venn diagrams, what we need to do is put the two circles together and draw it this way. So this is set A and set B. So in the middle is the intersection of A and B, which contains these elements, 4 and 5. Now A also contains 3 and 7, and B also contains 2 and 8. But 4 and 5 is common to A and B, so we put that in the middle. Now the union of these two sets is basically everything. It contains the numbers 2, 3, 4, 5, 7, and 8. And I'm running out of space. So this entire system with the two circles represents the union of A and B because it contains all the numbers 2, 3, 4, 5, 7, and 8. But the intersection is limited by this region here because it only contains the elements common to both sets. So hopefully this helps you to see the relationship between intersection of sets and union of sets as it relates to Venn diagrams. So that's it for this video. Thanks for watching and have a good day.